Hey everyone, welcome back. Today we're going deep on a tool that's making some serious waves, especially if you're a senior engineer dealing with complex systems, which, let's be honest, you probably are.
Yeah, definitely a familiar scenario for most of us.
We're talking about airflow. Maybe you've heard the buzz, maybe you've even dabbled in it a bit. Our mission today is to give you the rundown enough to know if it's something worth exploring further for your projects, or at least, enough to sound informed when it comes up in those meetings.
Exactly. No one wants to be the one nodding along when they have no clue what's going on.
So let's start with the basics. What exactly is airflow? They call it a workflow engine, but what does that actually mean for someone who, lives and breathes code?
In the simplest terms, think of it as the conductor for your data pipelines. All those intricate steps, dependencies, potential bottlenecks, Airflow steps in to manage the whole orchestra.
Okay, that paints a nice picture. But how does this translate into tangible benefits for a seasoned engineer like myself? Why should I care?
Well, remember all those late nights troubleshooting production issues because some task failed or a resource got overloaded. Airflow is designed to prevent those headaches. It ensures tasks run in the right order, even in the most complex workflows, and handles resource limitations gracefully.
Less firefighting at 2 a.m. I'm already listening.
Exactly. Plus, it provides comprehensive tracking and logging, so if something does go wrong, you can pinpoint the issue quickly and efficiently.
Okay, so that's for data pipelines. But can this conductor handle other types of projects as well?
That's the cool thing about Airflow. While it excels in the data world, its principles are surprisingly versatile. Think CI/CD pipelines, infrastructure management, machine learning workflows. If you can break it down into a series of steps, Airflow can likely orchestrate it.
All right, so we're talking about a pretty universal tool here, but there's this jargon that always seems to pop up: DAGs, tasks, task instances. Can we demystify those a bit?
Sure, they sound intimidating, but they're really not that complex. Let's start with DIGs, which stands for Directed Acyclic Graphs. Think of it as the blueprint of your workflow, the map that lays out all the steps and how they relate to each other.
Acyclic, does that mean no infinite loops? There's a defined beginning and end.
You got it. It's crucial to ensure your tasks execute in the right sequence and the workflow actually completes. Now, within the DAG, you have tasks. Each task represents a single, well-defined unit of work.
So if I'm working with data, one task could be pulling data from an API, another one cleaning and validating it, and another running some analysis on that data.
Exactly. And the connections between those tasks, those are your dependencies. They define the order of execution. Airflow makes sure everything happens in the right sequence without you having to manually micromanage each step.
Got it. So what about these task instances? Is that just like a specific run of a task? Like if my DAG runs daily, each day would have its own set of task instances.
Spot on. Each time a DAG runs, it generates a new set of task instances. This allows you to track the progress and status of each run. Did it succeed? Did it fail? What were the logs? All that valuable information is associated with the task instance.
Okay, so it's like a granular view of every step in the workflow's execution. That makes a lot of sense.
Yeah.
Now, since we're talking about building robust and reliable systems, there's this concept that I think is super important, especially in the data world: idempotency.
Absolutely. It's all about making sure that no matter how many times you run a task, as long as the input is the same, the output will always be the same.
So if a task fails and needs to be rerun, we can be confident it won't mess things up or introduce inconsistencies.
Exactly. It's like that safety net that ensures your data pipelines are predictable and reliable. It takes a lot of guesswork out of troubleshooting and helps you sleep better at night knowing your workflows are robust.
Fewer production surprises.
Mm.
I like the sound of that. All right, so we've talked about the high-level concepts, but what's happening behind the scenes to make all this magic work? What's the architecture of Airflow like?
It's actually pretty elegant in its design. You have four main components: the web server, the scheduler, the executor, and the metadata database.
Let's unpack those a bit. I'm guessing the web server is our interface, what we interact with directly.
Exactly. It's the friendly face of Airflow, built on Flask. It gives you that visual control panel to monitor your DAGs, track task status, dig into logs, and basically manage the whole system.
And what about the scheduler? What role does it play in this whole setup?
Think of the scheduler as the brain of the operation. It's constantly running in the background, analyzing your DAGs, figuring out which tasks need to run and when, taking into account all those dependencies and schedules you've defined.
So it's like the master planner, making sure everything happens on schedule.
Exactly. But someone still needs to actually do the work, right? That's where the executor comes in. When the scheduler says go, The executor takes the task and runs it.
All right, so we have the brain, the brawn. Now, where does the metadata database fit into this?
It's like the central nervous system of Airflow. It stores all the information about your DAGs, tasks, connections to external systems, variables, even the history of all past runs.
So it's like the library of our workflow universe, keeping everything organized and in sync.
Precisely. The scheduler, web server, and executor, they all rely on the metadata database to communicate and share information, keeping the entire system running smoothly. Now, one thing that really caught my eye about Airflow is this idea of workflow as code. It seems like a pretty big departure from how things are traditionally done.
It is, and it's a game changer, especially for senior engineers who are used to, dealing with complex systems and code bases.
So we're talking about defining our entire workflow, those gags, tasks, dependencies, all of that in code. Exactly. Instead of relying on visual editors or clunky configuration files, everything becomes code, just like the rest of your application. And that brings some significant advantages, right?
Yeah, I can already see how that would make things more maintainable, version controllable, even testable. But how do we actually define these tasks in code? What does that look like in practice?
Well, this is where Airflow's operators enter the picture. Each operator represents a single idempotent task. So remember how we talked about that same input always leading to the same output.
Yeah, the concept that's supposed to keep us sane and prevent those late-night debugging marathons.
Exactly. And the great thing is Airflow comes packed with a whole set of built-in operators for all those common tasks you can think of.
So we don't have to reinvent the wheel every time.
Right, you've got your bash operator for running those trusty shell commands, the Python operator for integrating your custom Python code, email operator if you need to send out notifications, simple HTTP operator for talking to web APIs, and even a bunch of database operators for, MySQL, Postgres, and others.
So pretty much a tool for every job, huh?
Most likely. And if you ever find yourself needing something super specific, you can always create your own custom operator, so it's pretty flexible.
That's awesome. All right, so let's get our hands dirty here. How about we walk through a real-world scenario, something that a senior engineer like myself might actually encounter?
Sounds good to me.
Imagine we're working on an e-commerce platform, something probably a lot of us have experience with. One common challenge is managing that whole pipeline for processing customer orders, right? You got to make sure inventory gets updated, payments are processed, notifications are sent, lots of moving parts.
Definitely a recipe for potential chaos if not handled properly.
Exactly. So how would we tackle this with Airflow?
Okay, well, let's break it down. First, you'd need to pull the order data from wherever it lives. That'd be our first task in the DAG.
Makes sense. What kind of operator would we use for that?
It depends on your setup. If your order data is in, say, a MySQL database, you could use the MySQL operator to grab it.
Okay, so we've got the order data. Now we probably need to do some sanity checks, right? Make sure the order is valid before we go any further.
Absolutely. You don't want to process an invalid order. For that, you could use a Python operator task, write some custom logic to check if the order is valid, make sure everything looks good.
And if it's not valid, what then? We probably want to alert someone, right? Like our customer support team, so they can reach out to the customer.
For sure, wouldn't want to leave any angry customers hanging. That's where the email operator would come in handy. You can set it up to fire off an email if an order fails validation.
Okay, so let's say the order's all good. What's next?
Now we got to update the inventory. This is where you'd interact with your warehouse management system, however that's set up. You might use another database operator or maybe a custom operator, depending on the system you're working with.
Right. Got to make sure we're not selling stuff we don't actually have. And after the inventory is updated, we need to let the customer know that their order is being processed. Right. Give them that peace of mind.
Definitely. Another email operator could handle that, or maybe you integrate with a messaging platform or something to send out a notification.
So just like that, we've built out a pretty solid DAG for handling customer orders, all with Airflow. And it's not just about automating those steps, it's about making sure everything happens in the right sequence with the right checks and balances in place.
Exactly. We've defined those clear tasks, set up dependencies, and even incorporated error handling. And once this DAG is set up, Airflow takes it from there. It handles the orchestration, the scheduling, the monitoring, all of that.
Now, let's say we want this order processing pipeline to run, I don't know, every hour. How would we handle that with Airflow? Do we need to mess around with cron jobs or something?
Nope, Airflow's got you covered. Right in your DAG definition, you just specify a schedule interval. It could be hourly, daily, weekly, even something more complex using cron expressions.
So we just tell Airflow how often we want it to run, and it takes care of the rest. Pretty
Yeah.
convenient.
Exactly. But of course, in the real world, things don't always go as planned. What if, let's say, that inventory update task fails? What happens then?
Good point. Got to be prepared for those inevitable hiccups.
Well, that's where Airflow's error handling and retry mechanisms come in. You can configure tasks to retry a certain number of times if they fail, and you can even define specific actions to take based on the type of error.
So we could, like, send out alerts for critical errors or even trigger a different part of the workflow to handle the exception.
Exactly. It's all about having those safeguards in place so you're not constantly putting out fires.
Sounds a lot more peaceful than how things usually go. Okay, another question. A lot of the data processing tasks we deal with, especially as senior engineers, are pretty computationally intensive.
Mhm.
How does Airflow handle parallel processing? Can it leverage multiple cores or machines?
It sure can. Airflow is built with parallelism in mind. You can define tasks to run in parallel within your DAG, and it'll distribute them across your available resources, whether that's multiple cores on a single machine or even a whole cluster of machines.
So we can take advantage of all that processing power without having to dive into the complexities of threading or multiprocessing ourselves.
Right, Airflow handles those low-level details so you can focus on the higher-level design of your workflows.
Okay, last question before we move on. We talked earlier about how workflow as code makes testing easier. But how do we actually implement that with Airflow? What does that testing process look like?
Since your workflow is code, you can apply the same testing principles you use for your application code. You can write unit tests for individual tasks, use frameworks like PyTest to make sure they behave as expected.
So, like with our order validation task, we could write tests to make sure it correctly flags invalid orders based on different criteria.
Exactly. And you can even do integration testing, running the entire workflow with some test data, making sure data flows correctly between tasks.
So we can test each piece individually and then test how the whole pipeline works together, end to end.
Exactly. And that's a big part of what makes Airflow so powerful, especially for senior engineers. It's not just about automation, it's about applying those engineering best practices, maintainability, testability, all of that to our workflows.
Welcome back, everyone. We've covered a lot of ground so far, from Airflow's core concepts to how it can wrangle those complex workflows we deal with, even dipped our toes into testing strategies.
And we left our listeners with a question to ponder what's next for Airflow. What does the future hold?
Right, because the data world's always changing, isn't it?
Hmm.
Got to stay ahead of the game. One trend I've been thinking about is serverless computing. It seems like it could be a pretty big deal for how we run our Airflow tasks.
Absolutely. Imagine running your Airflow tasks on something like AWS Lambda or Google Cloud Functions, paying only for what you use. That on-demand scalability could be huge.
Especially for those tasks that have, those bursts of activity but then die down.
Exactly. Makes Airflow even more efficient, more cost-effective.
And speaking of efficiency,
Hmm.
can't forget about containerization, right? Docker, Kubernetes, all that jazz.
Oh yeah, containers are a perfect fit for Airflow workflows. They solve that whole "it works on my machine" problem, making sure environments are consistent across development, testing, production.
Definitely. And with Kubernetes, you can manage the deployment and scaling of those containers, right?
Yeah.
Makes those complex Airflow deployments a lot more manageable.
Absolutely. So we're looking at a future where Airflow integrates seamlessly with these containerization tools, becomes even more flexible, even more scalable.
What else is on your radar when you think about the future of Airflow? What gets you excited?
One area I'm really interested in is how Airflow intersects with, well, with MLOps machine learning operations.
MLOps, yeah. If it feels like machine learning is just becoming more and more integrated into everything we do, right?
It is, and as machine learning models become, really core to our applications, we need the right tools to manage that whole life cycle from training and evaluation all the way to deployment and monitoring.
And that's where Airflow steps in.
Exactly. Airflow can orchestrate those various stages of building, training, deploying those models.
So we could use Airflow to automate things like, I don't know, retraining our models on frozen data, make sure our predictions stay accurate over time.
Absolutely. You can even integrate with tools like, let's say, MLflow or Kubeflow to manage experiments, keep track of different model versions, even deploy those models to different environments.
It's like Airflow is becoming this central nervous system for our entire data ecosystem.
That's a great way to put it. It connects the dots between all those data sources, processing steps, and ultimately the insights and actions we take based on that data.
Well, this has been an incredible deep dive into the world of Airflow. We've gone from, those basic building blocks to real-world applications. even peeked into the future.
Hopefully we've given our listeners a good sense of how Airflow can, really level up their game, help them build more reliable, more scalable, and ultimately more efficient data pipelines.
Before we wrap up, don't forget to check out the Pragmatic Reviews YouTube channel. If you enjoyed this deep dive, hit that like button, leave a comment, let us know what you think.
Keep those questions coming. And hey, as engineers, it's up to us to stay curious, keep learning, embrace those new tools and ideas that come our way.
Couldn't agree more. Until next time, happy coding, everyone.